metallic drain, waste, and vent, or DWV pipework should be bonded to the electrical system according to most electrical codes. This ensures electrical continuity and prevents the buildup of static charges. These charges could potentially create an ignition hazard. However, bonding of DWV pipework is not always consistently implemented in the field. Firstly, there may be a lack of awareness among plumbers and electricians. Secondly, there could be oversights or assumptions that the bonding has been done by other trades. Thirdly, there could be difficulty in reaching or accessing certain pipe sections. Fourthly, there may be concerns about potential water leaks at bonding points. The primary reasons for bonding metallic DWV pipework are electrical continuity, ignition hazard prevention, and grounding. Bonding connects all metallic components of the DWV system, ensuring the continuous electrical path. This prevents the accumulation of static charges. These charges could shock individuals or cause electrical malfunctions. Static charges can ignite flammable gases such as methane, which may be present in drainage systems. Bonding dissipates these charges, reducing the risk of an ignition hazard. The electrical bonding system connects the DWV pipework to the building's grounding electrode system, providing a path for fault currents to discharge safely. Bonding of DWV pipework involves using bonding clamps or other approved methods to connect the pipe to the electrical grounding system. The specific requirements may vary depending on local codes and regulations. Proper bonding of metallic DWV pipework ensures electrical safety, reduces the risk of ignition hazards, and improves the overall reliability of the electrical system. While the technical requirement for bonding metallic DWV pipework exists, its implementation in the field may not be universal. It is important for plumbers, electricians, and building inspectors to be aware of the bonding requirements. This ensures that they are followed to maintain electrical safety and code compliance. The NEC, or National Electrical Code, provides guidelines for electrical installations. These guidelines are not laws, but rather a set of standards that are widely adopted by jurisdictions to ensure safe electrical practices. In the context of bonding metallic DWV pipework, the NEC addresses the need to create an electrically continuous path. This is achieved by connecting all metallic parts together and grounding them. This is so that any fault current can safely return to the source. Several sections of the NEC are relevant to this topic. They cover the requirements for grounding and bonding of electrical systems and equipment. For example, NEC Section 250.104 discusses the bonding of metal water piping systems and other metal piping that may become energized. It is important to consult the latest edition of the NEC and any applicable local codes for specific requirements in a given area. Local codes may have additional or more stringent requirements than the NEC. When installing bonding jumpers, it is important to use appropriately sized conductors. The size of the bonding jumper is determined by the size of the overcurrent protective device in the circuit. NEC Table 250.102 Seat 1 provides guidance on the minimum size of bonding jumpers based on the size of the circuit conductors. The bonding jumpers must be securely connected to the metal piping using approved bonding clamps or connectors. These connectors must be listed for the purpose of grounding and bonding. They must be installed in accordance with the manufacturer's instructions. It is also important to ensure that the bonding connections are accessible for inspection and maintenance. They should not be concealed behind walls or ceilings where they cannot be easily inspected. In addition to bonding the metallic DWV pipework, it is also important to bond any other metallic components. This includes gas piping, HVAC ductwork, and structural steel. All of these metallic components should be bonded together. This will create a comprehensive grounding system that protects against electrical hazards. The purpose of bonding is to create a low impedance path for fault current to flow back to the source. This low impedance path allows the overcurrent protective device, such as a circuit breaker or fuse, to quickly trip and energize the circuit. This protects people from electrical shock and prevents damage to equipment. In situations where non-metallic piping is used, such as PVC, bonding is not required. However, It is still important to ensure that any metallic components that are connected to the non-metallic piping are properly bonded. This includes metallic faucets, shower heads, and other fixtures. Static electricity can build up on non-conductive surfaces. This is especially true in dry environments. While bonding is not required for non-metallic piping, it may be necessary to take other measures to prevent the buildup of static electricity. This includes using anti-static sprays or installing grounding maps. The installation of a proper grounding and bonding system requires careful planning and execution. It is important to consult with a qualified electrician to ensure that the system meets all applicable codes and regulations. A qualified electrician will have the knowledge and experience to properly size the bonding conductors, select the appropriate connectors, and install the system in accordance with the NEC and local codes. Regular inspections and maintenance of the grounding and bonding system are essential. This ensures that the system continues to function properly over time. Bonding connections should be checked periodically to ensure that they are tight and free from corrosion. Any damaged or corroded component should be replaced immediately. In addition to the NEC, other standards and guidelines may be relevant to the bonding of metallic DWV pipework. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. These standards provide additional guidance on the design, installation, and maintenance of grounding and bonding systems. When working with electrical systems, it is important to always follow safe work practices. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves. It also includes energizing circuits before working on them and using lockout/tagout procedures to prevent accidental re-energization. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Improperly installed electrical systems can be dangerous and can create a risk of electrical shock or fire. The bonding of metallic DWV pipework is an important aspect of electrical safety. By following the requirements of the NEC and local codes, you can help to ensure that the electrical system is safe and reliable. This protects people from electrical shock and prevents damage to equipment. The electrical system's grounding and bonding are critical for safety and proper operation. Grounding provides a path for fault current to return to the source, this stripping the overcurrent protection. Bonding connects metallic components. It equalizes potential, reducing shock hazards. These are distinct but related concepts. The grounding electrode system is a network of conductors and electrodes that connect the electrical system to the earth. This system provides a low impedance path for fault current to flow back to the source. This allows the overcurrent protective device to quickly trip and energize the circuit. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. These electrodes are connected to the electrical system using a grounding electrode conductor. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The NEC provides guidance on the minimum size of the grounding electrode conductor. The grounding electrode system must be installed in accordance with the NEC and local codes. The electrodes must be buried to a certain depth and must be located in an area that is free from frost heave. The grounding electrode conductor must be protected from physical damage. Bonding is the process of connecting all metallic components of the electrical system together. This includes metal conduits, metal enclosures, metal piping, and metal equipment. Bonding creates an electrically continuous path that allows fault current to flow back to the source. This allows the overcurrent protective device to quickly trip and energize the circuit. Bonding is typically accomplished using bonding jumpers. These are short lengths of wire that connect the metallic components together. The size of the bonding jumpers is determined by the size of the circuit conductors. The NEC provides guidance on the minimum size of bonding jumpers. The bonding jumpers must be securely connected to the metallic components using approved bonding clamps or connectors. These connectors must be listed for the purpose of grounding and bonding. They must be installed in accordance with the manufacturer's instructions. In addition to bonding the metallic components of the electrical system, It is also important to bond any other metallic components that may become energized. This includes gas piping, A-track ductwork, and structural steel. All of these metallic components should be bonded together to create a comprehensive grounding system. The purpose of bonding is to equalize the potential between all metallic components. This reduces the risk of electrical shock. If a person comes into contact with two metallic components that are at different potentials, they could receive an electrical shock. By bonding all of the metallic components together, the potential difference is eliminated and the risk of shock is reduced. The grounding and bonding system must be regularly inspected and maintained. This ensures that the system continues to function properly over time. Bonding connections should be checked periodically to ensure that they are tight and free from corrosion. Any damaged or corroded component should be replaced immediately. The grounding electrode system should also be inspected to ensure that the electrodes are still properly buried and that the grounding electrode conductor is still intact. If the grounding electrode system is damaged, it should be repaired or replaced immediately. A properly installed and maintained grounding and bonding system is essential for electrical safety. This protects people from electrical shock and prevents damage to equipment. The NEC provides detailed requirements for grounding and bonding. These requirements must be followed to ensure that the electrical system is safe and reliable. Consulting with a qualified electrician is essential for ensuring that the grounding and bonding system is properly installed and maintained. The cost of installing a grounding and bonding system will vary depending on the size and complexity of the electrical system. However, the cost of a properly installed grounding and bonding system is well worth the investment in electrical safety. The grounding and bonding system is an important part of the overall electrical system. It should be treated with the same care and attention as any other part of the system. By following the requirements of the NEC and local codes, and by consulting with a qualified electrician, you can help to ensure that your electrical system is safe and reliable. Remember that electricity can be dangerous. Always follow safe work practices when working with electrical systems. If you are not qualified to work on electrical systems, hire a qualified electrician to do the work for you. Your safety and the safety of others depends on it. Understanding electrical continuity is key. Electrical continuity refers to the presence of a complete and unbroken path for electrical current to flow. In the context of DWV systems, electrical continuity is achieved through proper bonding of all metallic components. This creates a continuous electrical path from one end of the system to the other. When electrical continuity is present, any fault current that enters the DWV system will have a low impedance path to flow back to the source. This will cause the overcurrent protected device to quickly trip and energize the circuit. When electrical continuity is absent, fault current may not have a clear path to flow back to the source. This can result in the buildup of voltage in the DWV system, which can create a shock hazard. Electrical continuity is essential for ensuring the safety of the electrical system. It protects people from electrical shock and prevents damage to equipment. The NEC requires that all metallic components of the electrical system be bonded together to create an electrically continuous path. This includes metal conduits, metal enclosures, metal piping, and metal equipment. The bonding connections must be made using approved bonding clamps or connectors. The connectors must be listed for the purpose of grounding and bonding. They must be installed in accordance with the manufacturer's instructions. The bonding connections must be accessible for inspection and maintenance. They should not be concealed behind walls or ceilings where they cannot be easily inspected. Electrical continuity can be tested using a multimeter. A multimeter is an electronic instrument that can measure voltage, current, and resistance. To test for electrical continuity, set the multimeter to the continuity setting. Then place the probes of the multimeter on two different points on the DWV system. If the multimeter indicates continuity, then there is a complete and unbroken path between the 2 points. If the multimeter does not indicate continuity, then there is a break in the path. If a break in the path is found, it must be repaired immediately. The break may be caused by a loose connection, a corroded connection, or a damaged component. Repairing the break will restore electrical continuity and ensure the safety of the electrical system. Maintaining electrical continuity is essential for ensuring the safety of the electrical system. Regular inspections and maintenance of the bonding connections will help to prevent breaks in the path. Replacing any damaged or corroded components immediately will also help to maintain electrical continuity. Remember that electricity can be dangerous. Always follow safe work practices when working with electrical systems. If you are not qualified to work on electrical systems, hire a qualified electrician to do the work for you. Your safety and the safety of others depends on it. In conclusion, bonding of metallic DWV pipework is crucial for electrical safety. It ensures electrical continuity, prevents static charge buildup, and provides a path for fault currents. While not always consistently implemented, awareness and adherence to codes are vital for plumbers, electricians, and inspectors. This maintains safety and code compliance in buildings.